Welcome back to another episode of From the Luthier's Workbench. Today I'm going to be covering part 14 of my oak kitchen tabletop guitar build. And what that means is I'm going to be wiring up the electronics. Not just talking about it, but actually doing it. However, before I jump into that, I should explain what I'm going to be doing is using a wiring diagram that was prepared for me by a company called GuitarElectronics.com. There'll be a link in the description below if you'd like to check out their website as well. But I've used Guitar Electronics several times in the past, and I know many of you have probably come across their website before. They offer not only the components, all your pots and switches, jacks, capacitors, wiring, all that. But they also provide some free diagrams for wiring up guitars. Now, most of these diagrams follow the most popular and common ways of wiring guitars. But every so often we run into a situation where we're going to wire a guitar using an approach that isn't maybe as common. And they offer the service of drawing up those schematics for you. And all you have to do is provide as much detailed information as possible so that they can prepare that schematic. And of course, if necessary, they'll contact you in return if they have questions about what it is you're trying to do. And they may even alert you as to whether or not it's even possible to do that. But for this project, since I'm going to be using a 6-way 4-pole rotary switch, I thought this would be a good opportunity to try out their service and see what they came up with. Now, I've got enough experience with wiring all kinds of different scenarios, so I have a pretty good idea of whether or not this schematic they prepared for me is going to work. But I'm going to go ahead and wire it up, and then I'll let you know what the outcome is. So let me bring you in a little closer and we'll get started. Let me kind of walk you through some of the tools that I use when I'm putting together all the electronics for a guitar. I always make sure I have my X-Acto knife handy, and I've got a set of, these are really old needle nose pliers. And then several years ago I picked up this wire stripper. This is a Pros Kit CP301G, and I'll try to put links to all these tools down in the description below. But this is a really nice stripper because it can strip wire the insulation from 20 gauge all the way down to 30 gauge. And that's really useful when wiring guitar electronics because some of the wires are quite small. And having a stripper that goes down to 30 gauge is really useful. I also have this block of wood. This is just a scrap piece of mahogany. And I drilled a bunch of holes in the top so that I can place all the components where I can solder everything together. Now you're probably wondering, why am I not doing this in the guitar? Well, I prefer to wire up as much of the electronics as I can outside of the guitar before installing it into the guitar. And the reason for that is I've already applied my finish. And the more you handle a guitar as you're doing work like soldering and connecting pieces together and bolting stuff on, the greater the chances of scratching or damaging that finish. So I'll try to set the guitar aside for now and do all the wiring I can outside of it. It's also easier to get to the components as you're wiring them. You can move stuff around, and there's nothing that is constricting access to all these little tiny prongs that you have to solder up with exceedingly small wiring. And speaking of wiring, I try to keep things as organized as possible, and I always will try to keep the signal wire one color and my ground wire another color. And for the signal wire, I will often use, this is just a red insulated 22 gauge stranded wire. And then for my grounds, I typically will use a black stranded 22 gauge wire. Now for this build, I'm going to be doing something a little bit different. Instead of using just your ordinary insulated signal wire here, I'm going to be using a single conductor shielded wiring. And as I mentioned in the last video, this has a single conductor core, which is just stranded wire that's insulated, and then wrapped around that insulation is the this is the shielding, and it's just stranded wire that wraps around it. And by twisting those strands together, I can solder it like to the back of a pot, and that will ground the shielding because the pot itself is grounded, so that ground is transferred to the shielding, and that helps to shield the wire. And what I've always found in wiring guitar electronics is the source of interference that can create noise in your signal usually comes from the wire, because the wire acts like an antenna, and wiring is generally not shielded. Now, I'm using shielded wiring on my humbucker as well as my single coils, so since that shielding will be grounded, I don't have to worry too much about interference entering the wiring coming from the pickups. But from the wiring that is going to be connecting the controls together, I do need to be concerned about shielding that wire. Now, unfortunately, with this diagram that I'm going to be following, and this is the diagram that I'll be using. This is prepared by Guitar Electronics and shows, you know, the 6-way switch, a master volume, master tone, the jack, and my 3 pickups. Some of these wires are going to be really short jumper wires, and unfortunately I won't be able to use shielded wiring in that case. Also, this structure itself can't really be grounded like a pot can. By grounding the case of the pot, we shield it from interference. So unfortunately, the jack or the 6-way switch can't really be shielded, but we'll see if that makes a difference, if that causes a problem. If it does, then I can always put copper foil in the cavity to completely encase everything in a grounded shield. Now, the soldering iron that I'm going to be using is a Cialotti soldering iron, and this one is the SSA 51, which I believe is still available on the internet, and I will try and put a link to this specific soldering iron because it's very affordable. And the cool thing is I can adjust the temperature, and it adjusts from like 200 degrees all the way up to 400 degrees. And I find that that is really useful for most of the soldering operations that I do on guitar electronics. And so I typically will just set this for 400 degrees and just leave it there. But then what I also like to do is I have a fan, which you can't see. I keep it off camera here, and it's not running at the moment because it does make a lot of noise. But that fan will blow across the surface here and will carry away any fumes generated by the solder. And the solder that I'm using is Kester. This is a 0.80 millimeter diameter solder, and it contains lead. It's a rosin core solder, but it is there's a percentage, and I can't remember offhand what it is, but it does contain lead. So I always use lead solder when I'm soldering electronics. I have never had much luck using the lead-free solders. I always tend to get broken solder connections. So, but I'll just run my fan and blow those fumes away from the work area as I'm soldering. Now, the first thing I'm going to do before I start to connect wires is I'm going to tin all the lugs where I'll be attaching wire. And that just makes the process so much easier for soldering. And the way I do it is I'll heat the lug with a hot soldering iron, and then I'll just touch it with a little bit of solder and let it flow into that lug. And then for the back of the pots, I typically will put a large blob of solder so that I can connect my ground wires. So I'll just heat that little section of the back of the pot with the tip of my soldering iron, and then I'll start to apply the solder. And you can see how it runs out and it's nice and shiny. And that's all there is to that. Now I don't have my fan running at this point because it's too noisy. But typically the fan would be running and blowing the smoke that's coming off the tip of the soldering iron away from where I'm working. Now the way that this schematic has been planned for is in the first position of the rotary switch, I want just the bridge pickup selected. Then in position 2, I want the middle. Position 3, I want the neck. Then in position 4, I want the bridge and the middle pickups. Then position 5, I want the bridge and the neck. And then in position 6, the final position, I want all 3 to be selected. So that's kind of how that's going to work. Now when I solder the components together with wire, I try to keep the wire as short as possible. And the first thing I'm going to do is strip off the end of the wire, and then I will twist those strands together. And then I'm going to tin it with solder just like I did the lugs. That helps make soldering the wire to the lugs easier, and it results in a much better connection. So you can see how that's now loaded with solder. So to make that connection, this is going to be the ground lug, or this will be the ground wire running from the ground lug on the jack. So I just have to heat that solder I applied earlier, run the wire through and let it cool. And I have a nice shiny solder joint. Then I'm going to figure out how long I need this to run. And it's simply going to go to the back of this pot. But when the guitar is actually hooked up, the jack is going to be probably clear over in this area. So I'm going to cut the wire to be roughly 5 inches in length, just for that. And then again, I will strip off the end, twist the strands together, and this is a helping hands, I don't know what, helping hands holder. It holds wire, makes it easy to solder stuff when you've only got 2 hands and one hand is holding your roll of solder and the other is holding the soldering iron. But when you solder, the solder, once it melts, it likes to flow to the hottest point, which is typically the soldering iron. So I place the tip right at the end of the wire, and then I'll place the solder further back, closer to the insulation. And once that wire heats up, that solder will melt and flow right up to the tip. And in doing so, it fills the strands of bare wire with solder. So now I'm going to connect this to the back of my pot, and this is going to ground the pot, which in turn can then ground this pot by attaching those with the jumper. So I just need to heat up this blob of solder that I put down earlier, get it to melt, and then I'll just slide that in there. Let it cool, nice and shiny. The ground wires are now attached, so what I'm going to do next is start to install the signal wires. And this is one of those shielded single conductor wires. So I have to kind of peel away the bare stranded wire that wraps around this insulated core. And I'll just twist those together, and this end will be soldered to ground. So I will tin it just like I did all the other lugs and wire ends. But I try to keep the core as short as possible so that as much of the core is wrapped in insulation as possible to prevent interference. So I am going to tin those. And then I'm going to figure out the length of wire I need. And this is going to run from the jack to the center lug on the volume pot. And remember, the jack's going to be clear over here. So I need to make sure that I'm running enough wire, and that should be enough. Now with this end is going to be soldered to the jack. So I don't need this stranded shield. I can clip it away because I only want to connect one end of that shield. And then I'm going to cut this short, strip the end, and then tin it. Now I'm going to solder this end to the jack. And then this end will solder to the middle lug, which I forgot to tin. And then the end of this, the stranded end that forms the shield, will be soldered to the back of the pot. There. Now I'm going to go ahead and install the capacitor. And that will install by soldering one end It's kind of hard to do this when you're shooting video at the same time. You got to watch where your hands are so you're not blocking the view. There. One of the things I believe most people will appreciate with a diagram like this is that instead of being a traditional electrical schematic, which can be tough for some folks to read if they don't understand the symbology of electrical wiring. But this does show visually where the wires will connect, and it's really clear as to where you're going to be connecting jumpers. And if you look at it carefully and think it through, you realize you can actually simplify some of the connections and use less wire. But for the sake of clarity, these plans do a really good job of showing the novice electrician how to wire up a connection like this. And here's a good example of simplifying the wiring in the schematic. I've soldered together 2 wires here, which will form one of the connections, and it just simplifies the process. All right, guys, well, that takes care of the wiring for this guitar, and I've got to say, thanks to my schematic from GuitarElectronics.com, I had no issues whatsoever. I followed their wiring diagram to the T, and no issues. I can select the pickups in a multitude of different ways. I can choose just the bridge or the middle or the neck by themselves, or I can select them in combinations, such as the bridge in the middle or the bridge in the neck, or all 3 of them if I want to get crazy. But the schematic really worked out. Having a resource like GuitarElectronics.com, I think, is great for having the ability to come up with a wiring schematic that you know is going to work. And if you've got this idea and aren't sure if it's going to work or not, they'll let you know. They're going to review your concept, and if it's not feasible, they're going to email you back and say, listen, this isn't going to work. Let's try this instead. And for a little bit of money, a lot of thinking is done for you. So then once you got the schematic in hand, all you have to do is just solder everything together and go. And as you probably already know, a lot of these components that you use in your guitar are fairly delicate. So when it comes to soldering, desoldering, and then resoldering, you can eventually get to the point where all that heat has damaged the component that you're using. So you really don't want to experiment with these. You want to know what what the outcome is going to be before you even turn on your soldering iron. And having one of these schematics is going to do that for you. Plus, when they create it, you can order all the parts that you need to accomplish that scenario. So it's kind of a one-stop shop, and they definitely get my thumbs up. So speaking of thumbs up, I hope this video is inspiring and gives you some useful information. If so, please give me a thumbs up. That always helps. And if you're looking for a way to support this channel and get something in return, head over to eGuitarPlans.com, purchase a plan for a guitar or one of the tools that I use to build guitars. And even if you don't build whatever plan you purchase, you just know that that money is helping to support this channel. So in the meantime, take care, stay safe, and I'll see you in the next episode, which should be episode 15 of this guitar build. So we'll see you then.